Okay, so for our next problem, we have to factor completely. And the first thing that we should ask ourselves, is there a greatest common factor? In order to figure out what the greatest common factor is from each of these terms, I have to break apart each term into its prime factors. So I'm going to do that down below here. I'm going to pause it and then show you each factored out. So you can see the expression here. It's been broken up into its prime factors. And what we have to do is go to each term and identify what we have in common in each term. Do we have a 3 in each term? No, we don't. Do we have an x in each term? Yeah, we do. We have one x in each term. Do we have any other x's? No. Do we have a 3 in each? No. Do we have a y in each? No. A z in each? No. The only thing that we can pull out is the x. And what we have remaining on the inside of the parentheses is everything that we didn't circle. So 3 times 3 times x to the third, and then minus 6, things that we didn't circle. Multiply everything together. We have 2x's, 4y's, and a z, and then minus 2 times c. So our answer is B here. Our next question asks us to factor this trinomial, and at first glance I see that there's not a greatest common factor in each term, so I'm not going to have to pull that out. What I want to do here is figure out if there's two numbers that will multiply to make an 18 and add up to make an 11. What two numbers will multiply to make 18 and add to make an 11? Well, that would be a 2 times 9. That would give me an 18. If I add those two together, it gives me an 11. So x in the front here, x times x is x squared. And our answer is C. Okay, so for our next question, we have to once again factor. And I look at each one of these terms, and I notice that they're each even numbers. So I know I can at least pull a 2 out of each. But actually, each one of those numbers is divisible by 4. And if I factor out a 4 from each, I'm going to have the x squared. And then, let's see, we'll have a minus 17. X 4 times 17 is 68. And then, let's see, 288. If we divide that by 4, I get a 72. So from here, we have to factor again, and I'm looking at the parentheses, and I'm thinking, what two numbers will multiply to give me a 72 and add to give me a negative 17? So what two numbers multiply to make 72 and add to give a 17? So 9 times 8 is 72, and minus 9 minus 8 will give me a minus 17. Our answer has to be A on that one. Let's look at the next. Okay, so for our next question, this is another factor question. We have to break apart. I noticed that 6 and 24 have a common factor, and also M is in both. We can pull out a greatest common factor for this problem. I have 6 in both. I have an M in both. I can pull out a 6m from both terms, and I am left with an m plus 4 on the inside of the parentheses there. So our answer for that one is C. So for our next question, we're going to start off by identifying a greatest common factor. 20, 125, and 280 all have a common factor of 5 in each. So I can pull a 5 out of each one of these terms. 20 divided by 5 is 4. And 125 divided by 5 is 25. And let's see, 280. 280 divided by 5 is equal to 56. So from here, I have a trinomial. I've got factors. And the first term here is made up of two terms multiplied up front in the parentheses. And I'm going to try a 4r and an r, simply based off of the choices that I have in my answers. So 4r times r is 4r squared. Now what two numbers multiply to give 56? 7 and 8. So I'm going to try the 8, and the 7, just like my answer choice has given me. How do I know if that's right or not? I have to look at the outer 2 multiplied and the inner 2 multiplied and see if I can get up that middle number there. So the outer 2 gives me a 32R. The inner 2 gives me a 7R. I'm looking to get a 25R. I can get a 25R if 32 is a positive and 7 is a negative. So I'd have to have a minus 7 there and a plus 8 there. And yep, my answer is C. For our next question, we have to factor a difference. And we should see right away that 9 is 3 times 3, R is R times R, 25 is 5 times 5. Whenever you have this situation, this is known as a difference of two squares. And the way that you factor a difference of squares is essentially you have the same exact factors with different signs, plus 5 and a minus 5. We have no middle term, right? So the outer 2 is a minus 15R, inner 2 is a plus 15R. That's why we got no middle term here. And so our answer is A. Okay, so for our next one, I noticed right off the bat that there are no common factors. This is a trinomial that must be factored. V times B is B squared. Now, what two numbers multiply to make up 9 and add to make up 6? It's 3 times 3, so a plus 3 and a plus 3. So we have V plus 3 times V plus 3, which is V plus 3 squared. Okay, so for our next one, we have a variation of a difference of squares. 16 is 4 times 4, and x to the 6th is x to the 3rd times x to the 3rd. 25 is 5 times 5. So we have 4x to the 3rd times 4x to the 3rd. A 5 times 5 is 25. We need 1 minus 1 plus, and that gives us C. All right, so our next question is known as a factoring by grouping question. And I first identified that because I have 4 terms. We're starting with a power 3 in our first term. And what I want to do is I want to look at these first 2 terms and say, is there a greatest common factor in the first 2? Yeah, I can pull a 7n squared out of the first 2. So 7, let's see, 28 divided by 7 is 4. And then 35 divided by 7 is a 5. So what I want is to hopefully factor out of the last 2 terms and end up with the same exact thing inside the parentheses. I'm trying to pull something out of here such that I'll have the same exact thing inside my parentheses. Is there a greatest common factor of 16 and 20? Sure, you can pull out a 4 from both. And 16 divided by 4 is 4, 20 divided by 4 is 5. So from here, we have a common factor in both. And I can factor out a 4n minus 5 from both of these terms. And that leaves me with a 4n minus 5 times 7n squared plus 4. Now, it's not the same exact order, but the order of multiplication is not important. So C is our answer for that one. Okay, so we have another factoring by grouping. Okay, so for our next question, we have another factoring by grouping question because I see the 4 terms, and the power 3 with the first term. But on this one, I see that each one of these terms, each one of these coefficients and constants are all divisible by 7. Each one has a factor of 7. So I'm going to start things off by factoring out 7 from each. After I've factored out a 7 from each term, I see that these first 2 and these first 2, we can pull and factor out now. So I'm going to pull out of 5 and 40 a 5. So we have a 5n squared. So we're going to have inside the parentheses a n minus 8. And then from the minus 7n and 56, I can pull a minus 7 out. And I'm going to be left with an n minus 8 on the inside of my parentheses here. So what we want to do is focus on the factoring by grouping part on the inside of the parentheses here. So what do both of these terms have in common? They both have an n minus 8 that you can factor out of both. So I can pull an n minus 8 out of both, and I'm left with a 5n squared minus 7. And this leaves me with A for my answer. Our next question, we have to evaluate the function, which literally means plug that 10 in wherever there's an x. There's a 10 taking the x spot, so we're going to have the 10 take the x spot within the expression on the right. So we have a 3 times 10 minus 1, which gives me 30 minus 1, which is a 29. A is our answer. On our next one, same deal. We have to evaluate, and I see that I have 8 taking this n spot, and that means the 8 needs to take the n spot within the function on the right. So we have 8 squared plus 3, and we have 64 plus 3 gives us a 67 for our answer. All right, so for our next one, we have to perform the indicated operation, and we have a couple functions here, g of x and h of x, and we have to add them together. So we're going to take g of x, which is x squared plus 2. We're going to add it to h of x, which is a minus 3x plus 5. This is essentially an exercise in combining like terms. I only have constants that are alike, so I need to combine them, and I end up with B for my answer. So for our next question, once again, we have to perform the indicated operation. F of x and g of x, we have to subtract g of x from f of x. So f of x minus g of x. And this is the key here. We have to have the negative in front of the entire quantity of g of x. We have to distribute that negative, and then we have to combine our like terms. So 4x minus 2x is a 2x, and then minus 3 minus 2 is a minus 5. And that leaves us with A for the final answer. Okay, so for our next question, we have to find f dot g of x, and that means multiply f of x times g of x. I'm going to set it up. So we have f of x times g of x. We have to multiply everything in f of x times g of x. So I'm going to start off with x times minus 3x squared. That gives me a minus 3x to the third. X times minus 1 is a minus 1x. X times minus x is a minus x squared. Now we have to multiply over the minus 3 into each. And that gives us a minus 3 times 3x minus 3x squared is a plus 9x squared. Minus 3 times minus 1 is a plus 3. Minus 3 times minus x is a plus 3x. I have to combine my like terms here. And looks like I am going to end up with this for my final answer part. Our next question, we have to find g of h of 2. First thing I want to do is find out what h of 2 is equal to. So I plug a 2 into the h function and end up with a 4. That tells me that h of 2 is 4. So I'm going to make a substitution. We're now looking at g of 4 instead of g of h of 2. And I have to figure out what g of 4 is. I have a 4 in the x spot with a g. I need to plug it in, and that gives me a 2 times 4 plus 1, which is 8 plus 1, which is 9. All right, for our next question, we have h of g of x. So wherever there is an x within h, we're going to place that g of x function. I'm running out of time, so I'm just going to have to show you the answer. Okay, everyone, happy studies, and I'll see you in class.